Okay, I want to talk a little bit more about quadrantal angles and what we're going to do with this particular worksheet. Now, as we pointed out in class, a quadrantal angle is an angle that has a terminal side on either the x or y axis. So in degrees, those would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay. And of course, hopefully we know that in radians, that's 0 radians, pi over 2 radians, pi radians, and 3 pi over 2. Now, the main focus of our lesson today, or whenever you heard that lesson, was that on the unit circle, we can think of a point xy that falls on the terminal side of an angle as giving us the values for cosine of that angle and sine of that angle. That is, cosine theta is going to be equal to the x value, and sine of theta is equal to the y value. If we were to draw a picture here, okay, here's the terminal side of my angle theta. Okay, and let's pretend that this is a unit circle, so that means the length of this piece is exactly 1. And so whatever these coordinates are for theta, I can think of them as this cosine theta, sine theta. Okay, cosine is going to be my x coordinate, and sine theta is going to be my y coordinate. And that's true any place we are on the unit circle. Okay, so let's take a look at the unit circle and our quadrantal angles. Okay, let's start at 0. Okay, this is 0 degrees and also 0 radians. And if we were in the Cartesian plane, the XY plane, and I wanted to know how far or how do I get to this particular point, we go 1 to the right and we don't go up or down. So the coordinates here are 1 and 0. Okay? And so what this means is that cosine of 0 is equal to 1, and sine of 0 is equal to 0. Okay? And we went through all of the cases. Here's the 90 degrees. Here's the 180 degrees. We can scroll down and we'll see the 270 degrees. We went through all of those cases in the lecture and talked about what the sine and cosine values are. But they correspond directly to the x and y values. Again, cosine is going to be our x value, and sine of theta is going to give us our y value. All right, so when I go back to the table, okay, if we're talking about 0 degrees, 0 radians, okay, I want to remember right here, I want you to remember that sine of theta is equal to y, and cosine theta is equal to x. All right, and this is only true, I can't say this enough times, this is only true that we can just look at that x and y when we are on a unit circle. If the circle is larger than 1 unit, then we have to do something a little bit different. But on the unit circle, if I want to know the sine value of theta, then I can just look at the y coordinate. If I want to know cosine theta, I can just look at the x coordinate. So again, visualizing very quickly, if I'm talking about 0 degrees, we're out here. and this coordinate is 1, 0. So that means that my sine value, sine of 0 is 1, and I'm sorry, cosine of 0 is 1, and sine of 0 is 0. Okay? As far as these other values, every other one of these functions is defined in terms of sine and cosine, right? We know that tangent theta is equal to sine over cosine. So you can write that. You don't have to necessarily write it in terms of x and y, but this is sine theta over cosine theta. And so if I know my sine and my cosine value, then we get 0 over 1, which is equal to 0. Okay? Of course, cotangent is the reciprocal of the tangent function. So that would be 1 over 0. And this is undefined. We cannot divide by 0. Okay, so we'll just say undefined. All right, and we'll find out more about that a little bit later. Okay, so if you want to, you can put right here cosine theta over sine theta, or if you want to, you can say 1 over tangent theta, whatever your strategy is for figuring out what cotangent is. All right, for cosecant, remember that cosecant theta is equal to 1 over sine theta. So when I'm here for 0, sine theta is 0, so again we get 1 over 0. Cosecant of 0 is undefined. Okay, I'll just stop at UND. But you would write out UNDEF or the whole thing. Okay, undefined because we cannot divide by 0. Secant of theta is 1 over cosine theta. And all of this goes back to, what we learned in the first 3 sections. So if we have secant theta equals 1 over cosine theta, we know for 0, cosine theta is equal to 1. And so that gives us 1 over 1, which of course is equal to 1. Okay? You don't have to show all of your work. I showed my work because I'm explaining. But what we want to be able to do is identify very quickly the sine and cosine values because they're directly related to the coordinates on the unit circle for theta, and then use what we know about sine and cosine of theta to find the values for all of the other trigonometric functions.